The background for Phase One moving into multispectral imaging is that 5 years ago we started working with Bill and Mike, who actually got their hands on a Phase One camera, on an SDK, a piece of software to interface to the camera, and then they worked with their own software, their own filter, their own hardware solutions to build an advanced system for narrowband imaging. And they have been using this both for smaller projects, select projects at customer locations, and they've been using this for sales of systems into cultural heritage institutions. For the past 3 years, we have worked with Annette, specifically in Germany. Annette, with her background in conservation, has started by putting together a system which worked according to the guidelines made up by the British Museum and the Charisma team there. And Annette has been very successful with, let's say, building her own system. Now, based on the success of Bill and Mike and Annette, the solutions we could see, Phase One started 2 years ago to build a system internally in order to come up with something that was, let's say, easier to handle and that was a very flexible system. Now, the base for moving into solutions for multispectral imaging, I think there are 3 key elements. The first is the development of LED technology. We see today, and over the past not so many years actually, that powerful and precise narrowband LED lights are available, and we can use them both for accurate reflective work, and we can use them in combination with filtering to make and capture photo-induced luminescence, where the light coming from our LEDs is initiating effects in the materials, in the surfaces, in the paints, in the texture, and that is the use of the LEDs. Secondly, we have seen advances in software where machine learning and disciplines within software development has made it, let's say, much easier, much faster to build a set of advanced tools that makes calibration of these multispectral imaging systems easy, at least easy seen from the user. So what we are offering is a nice tool set that brings you quick and easily through focusing, equalizing of the lights, exposure settings, and alignment of all the images. And finally, the advances in sensor technology and cameras has provided for the a workflow and an operational situation where you are today working through live view. You know exactly what you're doing, you see exactly what's happening on the scene, and this means that there is a complete, immediate, and intuitive control of what's going on. This is also based on our cameras, the RxG cameras, where the accurate measuring makes it possible for us to refocus where need be as we move through the different wavelengths. So moving into today's program, we are going to first see Annette and a number of examples where she's been using the multiband type of lighting and system. We will then see Mike, and Yair, he will follow up with a little more details about what the system looks like and how it actually works. And at the end of the day, I will give you links and information about documentation so that you know where to dig into some of the background materials for what you've seen today.
Hello to all of you from Berlin. I'm Annette here. Today we are talking about basics, and so I will focus on this. But I would like to mention that we invite all of you who wanted to go further into MSI, please contact us and tell us your specific application requests. We will work with you then on your specific solution. But here now, I follow with some examples to show potential of what multispectral imaging can do. So in the beginning, some words about why multispectral imaging. And I could say, do it once, do it right. So which means if you are doing documentation in the visible range, it takes less time more to get a relevant stack of images thanks to this new automated system. So this stack includes multiple information of an object in a non-invasive way without touching it. Thank you. The imaging is generating 8 different image information, part in color, part in grayscale, as you saw here, in reflectance and photo-induced luminescence. So always a true color visible image makes part of the stack and is very relevant as reference to all the objects. So this kind of imaging could become a standard documentation workflow for many of us, respecting high-level color calibration and standard calibration. And standard calibration is something very important to have evaluation after of these images. The multiband workflow follow the Charisma manual, as Peter also mentioned before. And so in February this year, I've been in London at the British Museum at the Charisma review workshop, meeting with my MSI colleagues and discussing how to update the manual after 7 years, because having new light sources and other situation, now it's time to get to the next step. Only following calibration standards like Charisma all allows us to compare images wherever they have been captured. And then we have here the next slide. The Rainbow full automated system, as presented today, takes part of several analysis methods, and its strength is based on giving a very good overview of a relatively big area. And it's not only punctual where you can measure special things, but you can go up to A1 with 300 dpi by this camera, which can also be used to guide further selective investigation and measurements. Basically, I can say that MSI takes advantage of the properties of different materials. It shows the physical behavior of chemical elements under different illuminations. So the images show differences and similarities as well as, let's say, strange areas and distribution of material, for example. Mostly it is the first way of investigation, and it works very well on polychrome surfaces like paintings and wall paintings, textiles, documents, or metal objects, and other organic materials like the butterfly you see here. MSI can be successfully applied in art documentation and conservation, but also in industrial process controlling, in forensic investigation, and a lot of other areas like agriculture inspection, for example. So let's see now some examples to uncover the invisible. Looking on these butterfly images, which can be seen as an example representative for organic materials, we can observe that all 4 images show different things. On the right side, we see the visible image. It shows the butterfly how we do see it. And next to this image on the left, the UV-induced visible image shows yellow stains in the clear parts, which indicates that the so-called white parts could be contaminated on the surface, or that organic material is changing during aging process. And on the other hand, on the black and white image on the left, we can observe that the white part changed to 2 different grays. So this could indicate that what looks white in the visible image can be differentiated in other images in various materials or pigments. So let's say generally, material which looks to human eyes similar or equal can be differentiated by multispectral imaging. On this slide, the Rainbow solution can create at the same time, in the exactly same position, a multiband, and as you see here, a narrowband stack of the same object in less than 2 minutes. So you see here in the 16 reflectance narrowband images and how the object change appearance under different so-called narrowband illumination. But Mike will later tell more about this. So I only want to mention here that the strength of the system is that it can be created a multi and narrowband stack at the same time, creating a wide variety of valued information. Up to 39 images can be used for visual or statistical analysis then. Next slide, please. On this example, you can see a Bruegel painting, which we captured together with the conservator Laura Ludvigsen at the SMK, the State Museum in Copenhagen. The question of the art historians was if this is a real Bruegel the Elder. And multiband imaging delivered the image, which shows clearly the signature of Bruegel, which was covered by the brown pigments in the surface, and which was relevant for the authenticity of the painting, which reveals the signature of the author. Thanks to the infrared image, the longest wavelength in the capturing setup, it was really possible to differentiate the pigments and to penetrate the painted surface to show also the painting. Another interesting application for multispectral imaging is the restoration of readability of documents. On this image, we see on the left part a detail of a document of the 15th century. Iron gallic ink can become a problem during aging process. As you can see on the left side, readability isn't very good. On the other hand, on the right side, you see an example of a so-called modern document from the 60s from the ex-DDR. This in part very important documents like doctorate or certificates of ownerships are fading very fastly. And also, if the text is nearly disappeared, the original text can be recreated by one of images of the stack. In this case, it is an IR luminescence image, and on the other hand, the iron gallic, it was an infrared reflectance image. Added to the multiband imaging, Mike will mention further information about recreating readability by narrowband imaging combined with statistical analysis using special algorithms. From surfaces on paintings, this example shows how overpainted paintings can be revealed again by infrared imaging. We are looking under the painted surface of the actual painting, and we see the covered painting underneath. We see now red flowers, but underneath there is a painted landscape, as you can see here, and as infrared is really going underneath the overpainted painting. It can also be possible to reveal so-called underdrawings or pentimenti. Pentimenti could be strokes that have been changed and painted over. The word is Italian for repentance, from the verb pentirsi, meaning to repent. Often we find positions of hands, eyes, or feet positions changed. And in this image, you can see here how infrared radiation is able to show us the part underneath the pigments, mainly brown, yellow, and red, we see on the left side. And on the right side, on the infrared image, we see around the nose and around the eye that there is really a sketch done before using pigments and starting painting. Multiband imaging, in this case, can also reveal invisible image parts of a scene which have been invisible during centuries. This example shows the pigment Egyptian blue, which has a very special behavior using multiband imaging, invisible induced infrared luminescence imaging. It becomes really extremely bright, as you can see on the left side. And it helped in this special case in Switzerland in a UNESCO World Heritage Church in Mystaya to show the pigment distribution of this blue pigment underneath the surface and to make the scene visible in a new light to show how the original scene looked. It helps to understand better how it looked in the case probably around the 8th century when it was painted. Here you see on the left a part of the wall painting in visible light, how we do see it. And I have matched over the image information of the right image, which shows the blue pigment distribution. Now what we see that on the person on the left side, on the hair, there have been flowers painted, and we really do not see this now by our eyes, but they are still there. They are underneath the painted surface we can see, and it helps to understand better how the scene was painted when it was done. Last but not least, I want to show you an application of forensic investigation. In forensic investigation, it is very important, don't destroy evidence. And here I have two examples. On the upper row, we see a piece of textile. The left part shows how we see it by human eye, and the right part shows instead the exactly distribution of the gunshot residue on it, absolutely non-destructive. And the row below shows residues of body fluids on a carpet. On the left, again, how we see it, and multiband imaging shows clearly the residue distribution. I want to close this range of examples with a macro image of a 1 millimeter little stone sample. And I would like to mention that in some cases, the high resolution camera combined with a macro lens can deliver information thanks to the 100 megapixel digital back, which in some cases can make redundant microscopy analysis. And this was now a basic journey into some multiband reflectance and photo-induced imaging applications. And I would like to give up to Mike to continue with the narrowband examples.
Good day, it's Mike Toth here. I'm in the Washington, D.C. area. I want to speak to you about some of the objects we've worked on, papyrus, paper, and parchment. Usually I'm traveling all over the world on various conveyances on multispectral imaging projects, and I will give you some of the outcomes from some of those as we in our discussion today. As Annette and Peter have cited, this is something we've developed we've been working on this, Bill Christiansberry and I, for 2 decades now, starting with the Archimedes palimpsest, and developed techniques and work processes and technology that has advanced the system, and we're now proud to be working with Phase One over the past 5 years. But in the process, we've been able to, as Annette cited, reveal the unseen. But it is technology. It is science. Some people cite this as just the magic in the black box. But Harry Potter notwithstanding, we imaged a book with a basilisk recipe and pen. There are advanced technologies involved. Advanced work processes, and of course you, the people, trained in the system. And with Phase One, we believe we have made it so it's almost like magic, but there is a lot of science and technology. The science, derives back to, here's a page by Sir Isaac Newton showing how a rainbow is formed. And in his process, he shows how the light is broken up into narrow wavelengths from bright white light, and that's what we capitalize on. What we do is we shine narrow wavelengths of light starting in the UV through the visible and into the infrared onto an object, and it reflects off the object through a filter and into the Phase One camera, currently a 100 megapixel Phase One camera. We then end up with a stack of images. And that stack of images includes as reflected light, and also, because we have the filter wheel, the fluorescence off the object. You put a narrow wavelength, a short wavelength on an object, and it fluoresces in a longer wavelength. That is also productive in addition to the reflective. And then what we can do is process those images, and in doing so, we can reveal the unseen. Sometimes we find out we do it and end up with these pseudo colors. Now the process takes many forms. I've talked about the collection. Okay, you shine the lights on the object from these imaging panels that contain LEDs, low heat LEDs. You shine it onto the object, it reflects or fluoresces on the object, and you collect that. You get this stack of images. So that's the collection part, but there's other pieces too. The processing. What we do then is we can combine those images statistically using various tools. One tool we use is ImageJ, a medical tool, open source software, but we've got that as a plug-in so that you can just push a few buttons to get these pseudo color images or grayscale images, whatever is best for you, to be able to visualize the object. And there's different ways of visualizing. And I'll discuss both of these, or there's many, not just both, but one is to look at the different colors that better reflect or fluoresce, and to combine those to those that you can see best with your eye. All our eyes aren't the same. Some prefer grayscale, some prefer color, some prefer blue, some prefer green. The other is to plot the spectral response and to be able to compare different inks. For example, a project we did with Alberto Campagnolo and a team sponsored by the Council on Libraries and Information Resources here in the US to look at stains in medieval manuscripts on the parchment there. And so this proved very useful. The analysis is ultimately what we're looking for. How do we support the scholar, the police officer, whomever it may be, to get information that can help them add more information about the object? That includes just viewing it, as we've done with the Hill Museum and Manuscript Library in Minnesota, or at the Vatican in the bottom picture with Bill Christiansberry. Also, to relate this information with other scientific instruments, such as X-ray fluorescence and fiber optic reflectance spectroscopy on the right. Ultimately, this all depends on data management. It all depends on making the information portable and available and accessible. And you can go to OPEN, O-P-E-N-N, play on the English word open, as well as University of Pennsylvania Penn. And you will see some examples from Hill Museum and Manuscript Library and the Galen palimpsest taken with the Phase One cameras and available for public access. And so I'm going to discuss, we'll go through the transfer of information by human beings, starting with papyrus, one of the oldest means of transferring. And this was at Duke University Libraries. This is a cartonnage fragment that was used in a mummy mask during the Ptolemaic era. And here's a natural light photo, and you can see up above where in the upper half there's a thin layer of gesso. And with the multispectral imaging and processing, we were able to reveal, working with the Duke University digitization team, able to reveal the text underneath that layer of gesso. So here it is in natural light next, and with multispectral imaging and the processing. So you have this twofold process, the imaging and the processing. Now here's a grayscale image that shows that text, and this is what it says. If you don't read ancient Greek, because this is in the Ptolemaic period, it talks about issues with the harvest of grain. And this was important to the scholars. They had not seen this. This gave them more information about the Ptolemaic era in ancient Egypt. And they were quite excited about it. They thought this was awesome. So here's an example of papyrus, and there's many other examples of papyrus and the application of multispectral imaging. Next, we turn to parchment because information was transferred from papyrus to parchment as papyrus faded out around the, I believe, I'm not a paleographer, around the 4th through 6th century and on. So here's Ovid's Metamorphoses. And you can see up in the upper left margin, on this image, it's on the upper margin. You can see some marginalia that's been faded. And we imaged this, did the collection, did the processing. Now you can see different types of processing, and you can see the different types of processing revealed different artifacts, different features in the parchment leaves. And with that, with one particular processing with specific wavelengths, and we just chunk through a whole bunch of wavelengths, a whole bunch of processing. You see I get all different colors, get grayscales. You can now read this marginalia on the left side, and this offered more information about the user. Now, another example, one of the toughest we had was at the Vatican in the Biblioteca Apostolica Vaticana, where Peter was with us and Alberto Campagnolo, and a team from the wonderful team at the Vatican Apostolic Library. And they gave us this black hunk of parchment, Dexipus, on the Lemnian Wars. And this is what we saw. and it was black. So we did imaging over time. We had to refine our imaging, and after a while, we were able to bring out that undertext that was under this wash of iron gall ink. Now, this took not only advanced processing, but also advanced collection, because we had to, it was all fluorescence here. So we had long exposures. We were up to 2-minute exposures in the shorter wavelengths to get a signal there. Now, with the latest Phase One camera, with the CMOS sensor, we don't need those long exposures because we can bump up the ISO. And we've tested that and found that gives us wonderful results with shorter exposure. Better for the object, better speed and efficiency for imaging, and better results. So with that, next slide, we were able to bring out this commentary on the post-Alexander period in ancient Greece. Also, I cited the team working on the Stains project. Next slide. This is in University of Wisconsin, University of Iowa. And what we did was image different parchment manuscripts with stains from different libraries, different works. And then we were able to plot the results, the spectral response, and compare those to say, this is candle wax, this is coffee, this is wine, this is whatever it may be, which helps conservators, helps paleographers, helps understand. So we end up with lots of data and have to manage that data. Now, then we've discussed papyrus, we've discussed parchment, let's discuss paper. Here's First Folio of Shakespeare at the Folger Shakespeare Library with Bill and the scholar there, and they wanted to better understand the signature and when it was placed on the frontispiece of the Shakespeare First Folio. Same, well, with this Vesalius second edition, he was a early philosopher of medicine. If you look at the bottom, there's signatures of prior owners. So trying to understand who they were, it's fairly well effaced. What we were able to do is image this with the Phase One system, earlier system. And so you can see where the ink differs somewhat, we were able to see underneath. You look at that bottom one, you can see the light green versus the dark. Where the ink is identical, it is difficult to see that. So those laws of physics prevail. In this case, our 4th of July Independence Day holiday is coming up. Here's a letter to Paul Revere authorizing all support for him in his ride to warn the British are coming. The British are coming, with my apologies to my UK friends out there. And so you can see below, well, you can see a couple things. You can see the paper structure. You see the chain and laid lines here. You also see the watermark on the left side. And if we click the next slide, this processing, the imaging and processing brought out the pencil mark below talking about general warrant. Here's a warrant supposedly signed by our president after the Civil War, Ulysses S. Grant. There's no evidence of a signature, or very faint evidence. And so you can see very faintly there's Hamilton Fisk, who was the Secretary of State, but up and to the right, next slide, we were able to bring out the fact that Ulysses S. Grant did indeed sign this. And you can see the residue of tape here. You can see folds. You can see how it was folded. You can see the watermark below Grant to the right of Hamilton Fisk. You can see the watermark there. So features in the paper as well as the signature. And I'd like to thank you. I believe we'll have time for discussion afterward. There are a number of links to the data I've cited and discussing some of our work, including some that I haven't cited here. Our prior work with the Archimedes palimpsest in St. Catherine's Monastery and other imaging projects around the world. We stand by to support, especially those in the United States. If you're in a driving distance to the Washington, D.C. area, and we can do it safely, we are able to do similar to what is being done in Cologne. I turn it back over to the organizers here, and thank you very much.
Right, so hi everyone. I'm just gonna go briefly over the components, or let's say the structure of the system, what it actually contains in terms of hardware and software. The middle one is obviously the camera. I know it looks like a black box, but this is a Phase One IXG camera, 100 megapixels. It has a color sensor, RGB sensor, and we've supplied with everything that you need in order to make it into a normal camera, meaning a filter that you can place in front of the lens with a magnetic adapter, so you can take normal images with visible light, daylight, any kind of light, flash, and so on. On the left, this is the multiband option. You see two banks of lights with 3 lamps on each side, UV, visible light, and infrared, and they come with the relevant filters in front of them. They also have power switches, adapters, cables, and so forth. In front of the camera or below the camera, you see this black thin thing. This is a filter wheel, and it's motorized, remote controlled, all running through the same piece of software that runs the camera. On the right, this is the narrowband option. Narrowband means that, as Mike suggested and demonstrated, we basically slice the spectrum into narrower slices. Instead of using just 3 lights on each side, we have a panel on each side with 16 different LEDs. And again, they are all software controlled, and we can control the different configurations of a specific light with a specific filter or without a filter. We can create a stack or a preset stack, but we also allow you to create custom stacks. Just going through this quickly, you see the camera in the center, you see the copy stand, and the copy stand can be your copy stand, can be one of our copy stands in the 3 or 4 different flavors. The components with number 3 on them, this is the multiband, and you can see the 3 lamps with power supplies. And then you have the narrowband LED panels, and again, they also come with power supplies and cables and so on. And then, of course, there's software, Rainbow Software, which is installed on a laptop. The laptop is either spec'd by us and you purchase it locally, or we can also help with getting you with everything you need. And then there's, of course, accessories, USB hubs, and so on. This is the multiband, just looking at a little bit closer. So you see the filter wheel underneath the camera. The camera comes with 2 different lenses and extension tubes. So it allows you to cover larger objects, smaller objects for macro imaging, and so on. Narrowband, same configuration. It's just that the LED panels replace the lamps. To show you how it is all nicely packed, the filter wheel with a special custom rail that holds the filter wheel and the camera comes in a suitcase with all the accessories, and there's room in that suitcase for the laptop. The camera is very similar to a standard IXG camera, but as I said, there's no filter in front of the sensor. Instead, it has a clear glass filter, and it comes with an external filter and magnetic adapters. Then there is the special shroud that is custom made by ourselves, and its purpose is to block any stray light from coming through the sides and reflecting from the filter into the camera or onto the sensor. The lights, again, they all come nicely packed. If it's the multiband option, you see basically the same set on the left, same set for the right. All the power supplies and cables, and these black boxes are essentially USB controlled power switches. So again, the software allows you to turn the lights on and off. These lights are all adjustable in terms of angle and so on, and they come with a custom rail that adds extra flexibility in terms of moving them across the area that they need to cover. The LED panels come in a nice suitcase, and again with all the relevant accessories and regional power adapters and whatnots. To give you an idea of the configuration, and I was talking about the copy stands, we can supply a floor standing copy stand, a desktop mounted copy stand, and also a wall mounted copy stand. The wall mounted one gives you the extra flexibility in case you need to work on fairly large objects. So you can basically position the camera higher than normal, and then you can have the object mounted on a desk or a trolley or a book cradle or anything that you want to work with. The camera, the rail, and the filter wheel can actually come off the copy stand and be used on basically a studio stand or a tripod. So if you're working in a gallery or in a chapel, like the image that Annette was showing earlier, you can actually have the whole setup mounted on a tripod. Of course, you have the lights on the sides, on the light stands, and just work on site. Of course, you will still need the laptop. Worth noting that the camera is not a portable one in terms of having a CF card and batteries and so on. So it needs to be tethered to a computer, and it needs to run on some kind of a power supply. Annette mentioned working with Charisma and being part of the team that was developing the guidelines and so on. When we're talking about guidelines and calibration, for instance, it's all to do with how you set things up in terms of camera capture parameters and exposure, shutter speed, and so on, to get the right kind of exposure that will allow you to get the most out of the image in terms of detail, in terms of low levels of noise, and so on. Charisma specifies a set of 8 images, although we only capture 6 in that case, but we have the software that actually develops them into 8 images. Going to software, some of you are familiar with Capture One, which is a brilliant piece of capture software for capture, post-processing, editing, and so forth. We figured that for this specific application of having an object that needs to be captured with a very specific technology, with all these different wavelengths and so on, we decided to go with something very simple in terms of operation, and very smart in terms of capturing and then processing to the exact specifications. So we follow the concept of a 5-button workflow, setting things up, composing, capturing, and then processing. So when you set things up, you can choose a recipe. And recipe means you're working with a multiband, following the Charisma guidelines, or you're working with a narrowband and creating a much larger stack with a different type of images. And then you can also customize your recipes and create a very small stack with only 1 or 2 images in IR, for instance, because that's all you need, or even more. In fact, you can capture up to 39 images in a stack just by configuring different combinations of lights and filters. The software lets you have live view, where you use to compose and do the initial focusing, and from there it'll take over calibration. In calibration, I mentioned the exposure, but another very important part of it is alignment, meaning that when you change wavelengths and when your focus plane changes a little bit, the software will realign these images, meaning that when you then review the images, or when you put them into a third-party software that does some statistical analysis and so on, it makes sure that all the pixels are actually very accurately aligned, that there's no shift or any detail that's all of a sudden moving to one side. When we talk about the processing, you don't have to do anything. Once you've selected the recipe, you end up with a stack of 8 images, and these are already 16-bit TIFF files, ready for any kind of work review, visual review, and so on. This is just a list of what it is that we are capturing, and then what it is that we are processing. So starting with the visible light, and the visible light is also used for a live view. And again, you can turn it on and off from the software. So if you're working in a dark room, which is often required, you can turn on the visible light from the computer, do your live view, and then let the software do the calibration and the capture. Then you have the same visible light, but with an IR pass filter, and then you go into UV with a pass filter, and then with some block filters, and then UV, but with an IR pass filter to get a different type of reflectance, and the infrared reflectance at the end, and these are typically those black and white looking images. Then there's the list of the processed images. The 6 are more or less the same, and then you have the additional 2 false color images. False color means some of the channels are being swapped, and that allows you, as Annette explained, to spot specific pigments that normally would show as at a certain color coming up in a different color. So it allows you to, first of all, spot them, but then also understand things like their age and the part of the world they come from, and so on. And here I'll just show you just a visual example of what images look like. So these are the raw images shown in Capture One. So this is not the Rainbow software. This is basically just taking the raw images from the stack and looking at them in Capture One. And you can see the visible image on the bottom right, the visible light image. You have an infrared image, and then you have the UV and IR, and then you have these reflectance images, and they show up in black simply because in the subject matter, there is no pigment or material or anything that is actually seen through the filters. And then you go to the processed images, and here you can actually see the 2 false color images. Also worth mentioning that in all these images, there's this little target in the center, and this is part of the kit that we supply. It's made of a special type of silicon. And the key thing about it is that regardless of the wavelength that you're using and the type of light and so on, the values on it don't really change. So you can actually see that the white here is white everywhere, black is black everywhere. So if you're following something like Charisma, you always know that you're getting the best or the most out of the images.
That's great. Yeah. I will move into the wrap up and get the first picture. As I mentioned at the beginning, I'm going to give you insights to links and where can you retrieve information about the work that we have discussed today. And I will start as the number 1 with our website, the Phase One website, from which you have access to the cultural heritage part. And under the cultural heritage, there is an area called resources. And under resources, you will find all kinds of things, amongst them documentation. And on the right, number 2 here, is first our solution guide for cultural heritage solutions. And it includes also our multispectral systems, plus details on the camera systems and so on and so on. From the documentation side, you can also download the Rainbow brochure or the Rainbow documentation. And It describes both cases, it describes the details of the system that Yair was explaining just now. You can see that in quiet and see the different parts of it, and you can see some of the cases documented. On the back side of this document, you will find a series of QR codes, and just to start from the bottom, you see a QR code for RB Toth Associates. That's Mike's website where the cases and other cases are documented well. Above that, you have a QR code for Art Imaging Annette Keller. In here, you will see again a long list of cases for the multiband imaging, where you in detail can read about these different projects. Then we have a QR code directing you to the British Museum and the Charisma standard. If you want to read the details, it's a fairly extensive document, but it's really interesting in the sense that it describes a specific workflow to achieve the set of images we've been looking at, and also how to interpret those images in a standardized way. And it spoke of that this group around the Charisma, they are developing for a next level of these workflows, but they have not been published yet. So here you can see what the standard looks like today. And on top is the QR code to the Phase One team. At the right of this picture, as number 5, I've indicated the two types of multispectral imaging systems that we are offering under the Rainbow system. And what I want to mention is that these are available. They are available in Cologne, in our test center there, and they are available such that you can have a demonstration online, on Teams or on Zoom or on whatever, or you can arrange with Gerald or Annette in Germany to actually come there and make a demonstration in the office with materials that you can bring. Or you can ask us to come to your site and do projects or experiments or samples under your control in your environment. So here at the end of the day, I would just like to mention that we have seen quite a growth within multispectral imaging. And there are probably many reasons, but some of the reasons seen from our side is that, first of all, it has become easier to work with. Secondly, there is an interest growing because more and more cases, studies, discoveries are being published where multispectral plays a role. And then I think it's important for us all to be aware that the solutions we're showing today, they are open-ended. And we don't have a final result of where this ends. They are open-ended with regards to analysis of how surfaces, inks, paints, clothing, all kinds of materials, how they react to light, both in terms of the reflective light and in terms of the photo-induced luminescence that can be picked up. And again, we've shown you two methods, the multiband where it's visual analysis according to the standard of Charisma, or in narrowband where we very often use statistics to actually find and pinpoint the effects that can be discovered using statistical analysis. Now, we in the team that you have met, part of at least today, we are working to make it easier for you to get started. First of all, we have the solution of Rainbow with all the different types of setups designed for different types of applications. And we offer you access to this kind of solutions, either online to Cologne or to come to our premises. We offer to make a basic demonstration, but we also offer doing a workshop if you have a particular case, a difficult document, a painting that needs to be looked at. You've seen an example from Annette with the Bruegel painting. You've seen Mike show this special page at the Vatican. I mean, there can be very special cases where it makes sense to set up a workflow of a workshop of a couple of days, and we will be able to provide for that. Then there will be some of you who may already be into multispectral imaging. We can help you in the planning and analysis of specific projects, because sometimes to actually plan and do the right type of imaging will pave the way for the statistical analysis to get to good results. And then finally, of course, we offer our assistance for designing and operating a multispectral system if you plan to invest in such a system, both in terms of having it in-house, but also how to operate the system to get the most value out of your system.
I went through the questions, and I'll just go through them and point them to the relevant person, unless I can answer them. First question, or a couple of questions from Piotr in Norway, asking about the images that Annette showed in her presentation from the chapel with the blue pigment, and he's asking if they were shot in the chapel and what kind of camera they were shot with. They were shot, yes, in the chapel, and the camera was used was an XF, Phase One XF camera with a wide spectrum digital back. So while it's not a fully automated system, purely because it was taken a little bit earlier than when we actually had the system fully up and running, but the sensor technology and everything else around the workflow is essentially the same. So it was taken in the chapel with an XF. And I don't know, Annette, if you have any sort of behind the scenes images of the setup from that shoot. But if not, I believe we can find something similar just to demonstrate it. I know we did a shoot a few months ago in Vienna, in a gallery in Vienna that looked pretty much the same, so I can find some images from there if needed.
I could say it's exactly the same setup as we see on the left image here. It's the three light sources on a slider, so you have a tripod on the right and a tripod on the left, and you can use it also with battery packs if needed. And it's only changed that it's in horizontal position and not in vertical, but it's the same equipment on lights.
Okay, great. Another question from Piotr is the software compatible with Mac and PC? The software currently runs on a PC, but the way it's designed and the way it's been programmed, in theory, it can be compiled to almost any kind of operating system, including Linux and so on. But the development right now and the released version and what we're demonstrating and so on at the moment is PC only. Next question, or couple of questions from Greg, and I hope I got the gist of your two questions. Apologies if not. Well, first question is about capturing and revealing any detail in silver halides. So if you're shooting film, for instance, and I think maybe Annette can answer that, or Mike.
What I can say that I did experiences with daguerreotypie, and there we got informations out of. I never used it for transparent film materials to do it, so we could not have experience about it.
But this is something that, since we already have the system, it's something that we're very happy to experiment with, whether it's some samples that we pick up from somewhere, or if you have any specific material, or if you guide us to the kind of material that you're actually interested in, then of course we can do the testing for you. Greg's other question.
Let me add something here. We just imaged a 1904 photograph. It was a positive print. And the short wavelengths down in the UV and the blues brought out much more detail in the photograph, allowing us to better visualize the faces and clothing and the fine details, the lace in the photo that had been badly faded after hanging on the wall for 90 years. So it did provide positive results with a positive print from 1904.
That's great, because this actually answers Greg's second question, because the second one was about printed photos and old printed photos and the degraded ones and so on. So thanks for that, Mike.
We were using the narrowband system.
Cool, excellent. Next one. Lizardo is asking about capturing small objects, mentioning that they often work with objects as small as 10 centimeters wide. So with the IXG camera and the 120 millimeter lens with extension tubes, the smallest object you can cover is just over 6 centimeters wide. And that gives you about 4,500 ppi in terms of resolution. So things like small format prints, small postcards, or even miniature manuscripts and things like that, that's not a problem capturing them. I think next question is from Klaus. I think I'll let Annette answer that. It's why is it necessary to use colored light if you can also use the filter wheel? And of course, this is all not just the color of the light, but the actual wavelength and the intensity and so on. But Annette, maybe you can give a more practical example for this.
Yeah, it depends what we are doing. If we are doing reflectance images, it is not necessary to use the filter wheel, but we wanted to do also photo-induced luminescences, and there it is necessary because the illumination is a shorter wavelength than the wavelength you need to capture if you want to get a luminescence image. So this is the reason why if you do luminescences, we use the filter wheel. If we do reflectance, we could do it without it. And in the multiband, it's a little bit different because we can decide which kind of multiband we have. So we have also one filter for the whole width range, because so we can really be sure to get a perfect visible image like reference.
Okay, you also throw less light on the object with the narrowband, or without using the broadband, taking a series of pictures and just throwing every wavelength on the object. Instead, you're minimizing the energy that goes onto the object.
Yes, that's another plus of the system, especially when it goes to UV and things like that. And sometimes people might be a bit cautious about using UV radiation on these ancient objects and so on.
Right, we're down to 365 nanometers, which has proven to be benign for objects at the exposures we're using.
Yeah. Next question is also for you, Mike. And in your presentation, there was one slide where you were showing some charts and graphs coming out of the images. So the question is, where are these graphs coming from? What kind of software? And also if they are normalized values or just the absolute ones?
I can't, I believe they're normalized values. We usually normalize for each of the images, and those were done with the ImageJ software, which we've compiled into a Paleo toolbox. For more information, I think it's the Library of Stains project, and I believe all those data are up on OPEN.
Okay, cool. Let's see what else is there. Question from Kurt about chromatic aberration and how do we deal with it in the UV and IR spectrum. I mean, at least from my side, I can say that the lenses that we are used generally don't suffer from any of these phenomena, and plus the alignment that we do in the software and the light uniformity and so on, they all kind of take care of that. So we don't often see any issues with chromatic aberrations. Let's see if there's anything else. Question from Camelia about 3D objects, and have we ever tested the Rainbow software or the system on polychrome sculptures? And I think, Mike, you actually have experience with the mummies.
Yes, we have done 3D objects. The issue is, and we've gotten good results. The difficulty is trying to determine what is reflection, what is shadow, versus what are elements or features or artifacts within the object that are either fluorescing or reflecting in a specific wavelength. So it gets a bit more complicated because we can't do a flat field of an object, but we have had good results, I'll say, with identifying dyes and paints and residues on 3D objects. But it takes a bit more analysis to understand, is this a function of the object in terms of its response to the narrowband, or is this merely reflection or shadow? So one has to analyze it carefully.
Okay, thank you. Another question is about, yeah, it's actually pointing to mummies that are frozen at like -20 degrees. Trying to take pictures of these in some, to see if there's any pigmentation below the skin and so on. I think this could be just a general issue that you might experience when using any kind of digital equipment. So the cameras are, let's say, spec'd for I think -4 or -5, but much like any other cameras, if you take the relevant precautions of maybe keeping the camera itself warm or trying to cool it down slowly so you don't get any funny effects like a condensation on the lenses and so on, then everything should work. But at -20, a lot of things can happen to electronic equipment, as we know. That includes computers, cables, and so on.
Let me add, Yair, I think a bigger concern is the object and not thawing out the object. The LED lights are all low heat. They have internal heat sinks there, and the camera is low heat. So the issue is if there's any ice surrounding it, would that cause refraction or reflection? But with appropriate precautions for the object, for the equipment, and of course for the operators, and perhaps having a cable running to an outer room for the laptop or something, that it is feasible.
Once we're done here, we will be sending you an update email with a link to the recorded webinar. That might take a few days for us just to clean it up and edit it nicely. And then you'll get an email, and from there we can follow up and answer any specific questions. And as Peter mentioned, we are all available, so you can contact us directly through our contact us page on the Phase One Cultural Heritage website. But also, even if you reply to the emails that you received, we will be able to take up more questions and answer more of them. And then, of course, Peter also mentioned that we will be able to do demos and tests for you. I know it's difficult to actually handle the specific materials sometimes, and it's not easy to just post them to us, but we can do as much as we can remotely, and hopefully soon enough traveling will start happening to one level or the other, and we'll be able to possibly visit you, or you'll be able to visit us. And yeah, I think that's pretty much sums it all up. Peter, do you want to say anything extra?
I just want to say that it has been a pleasure to have you all listen in on us now for a little more than an hour. It has been really good to have a big part of the team available today online, and we hope to see you soon here or there. We will stay tuned, and we will be ready to do our best to get these projects rolling. So thank you very much. See you soon. Bye bye.